So this video is going to go through a couple of problems using Faraday's law, and so you'll see how these are done. So let's get started. First of all, just a couple things to point out. You're going to be given typically 2 of 3 variables, and then you're going to have to determine the third, and all 3 of these variables are pertaining to this equation for current I. Current equals Q, total charge divided by T, time. It's a logical step-by-step process, so just go through the steps, make sure you're covering everything, and it really is quite straightforward. You'll be given, and you'll need to use the Faraday constant. So that's that charge on 1 mole, total charge on 1 mole of electrons, 96,485 coulombs per mole. And you'll need to use the balanced half reaction. Okay, so if you keep that in mind, it's pretty straightforward. So without further delay, let's do one. So here we go. What is the mass of copper? So that's what we're looking for, the mass of copper. Now notice that's not one of the 3 variables, but we can get to that because one of the variables we can find or we use to find number of moles. Okay, so what mass of copper you plated onto the electrode when a current I equal of 10.0 amps is passed through a solution containing copper 2 for a period of time 30 minutes. So there we go. We have current I and we have time T. So therefore we're going to look for Q and onwards. Okay, so first, using current and time, we can find that total charge Q. So if you remember the equation, I equals Q divided by T. So therefore Q equals current times time, and so our current was 10 amperes. Now I'm going to actually convert that to the units we want. If you remember what an ampere is the same as or equivalent to coulombs per second, and so that gets my unit of time in there. So now I'm going to multiply by T, 30.0 minutes. But you'll already realize we have to convert minutes to seconds, and so there are 60 seconds in 1 minute. And then the unit analysis tells me I have the right answer. I have coulombs, that's what I'm looking for, total charge in coulombs, and I have 18,000 coulombs. Okay, so I've found Q. From Q I can move towards mass, and so first thing I have to do is using the total charge Q that I just found and the Faraday constant, I'm going to find the number of moles of electrons. And so number of moles of electrons equals this total charge Q, and I'm going to multiply it by some permutation of the Faraday constant. So I'd prefer to do multiplication, so I multiply it by 1 over F. This is the same as dividing by the Faraday constant. Okay, same thing. Anyway, so Q, 18,000 coulombs times 1 mole of electrons over 96,485 coulombs. And so coulombs divide out, and I'm left with moles of electrons, and I'm left with 0.1866 moles of electrons. Notice I'm carrying 1 extra sig fig. I have a 3 and 3. I have 1 extra one. Alright, so currently we have moles of electrons. So I'm just going to hang on to that number. Just put it up here. There it is. So I'm just going to put that over there for my reference. So now, using a balanced half reaction, find the molar amount of copper. So molar amount of copper is what we're looking for, but we need this balanced half reaction. So what's the half reaction for the reduction of copper 2? If you remember, it was copper 2 in the question. 2 moles of electrons. So there's our link, mass and electrochemical, or current, 2 moles of electrons. And so I have this many moles of electrons, so I want to find moles of copper. So number of moles of copper solid equals number of moles of electrons times, we've done this in grade 11, equation factor. And so the equation factor in this case, so it's 0.1866 moles of electrons times 1 mole of copper divided by 2 moles of electrons. Electrons divide out, and I'm left with how many moles of copper? 0.1866 divided by 2, which is 0.09327. 0.09327 moles of copper. And so then, lastly, I find the mass of my copper using the molar mass of copper and my molar amount. So I need to go to the periodic table, but mass of copper equals number of moles times molar mass, 0.09327 moles of copper times 63.55 grams per mole, molar mass of copper. Moles divide it, and we have 5.93 grams of copper plated. If we run a current through the solution, we would plate 5.93 grams in 30 minutes, or however long we did it. Was it 30 minutes? Can't recall. But there you go. So like I said, a logical process. You have to use the Faraday constant. You have to use a balanced half reaction. You do need this. And other than that, it's pretty logical. So let's look at one more. Okay, so here's the question. How long in hours must a 0.0750 ampere current be applied to an aqueous silver solution in order to produce 10.5 grams of silver metal? Okay, so the starting point is a little different. We have a mass of silver, and we know the molar mass of silver. So right away, we're going to find the number of moles of silver. So number of moles of silver equals mass divided by molar mass, 10.55 grams, divided by 107. Molar mass of silver is 107.87 grams per mole. So that equals 0.0978 moles of silver. Okay, so there's our molar amount of silver. Now, I need to convert this to moles of electrons. So for that, I need my balanced equation. So silver plus aqueous plus 1 mole of electrons yields silver solid. Okay, so my number of moles of electrons is very easy. It's the same, 0.0978 moles of electrons. Why is it the same? Because of a 1-to-1 ratio between moles of electrons and moles of silver solid. Okay, so there I have moles of electrons. Next, I'm going to find Q, total charge. I have my moles of electrons, so I'm going to find Q, and to find Q I use the Faraday constant. So it's number of moles of electrons times the Faraday. And so that is going to be 0.0978 moles of electrons times the Faraday, which is 96,485 coulombs per mole of electrons. So moles of electrons divide out. I'm left with coulombs, a total charge in coulombs, and this is 9,436 coulombs. So there we go. Now finally, so once I have coulombs, that's my total charge Q, and I know the current. We were given the current at the top, at the question, 0.0750 amperes. So now I have Q, and I already have current, so I can find T, which is what the question is, how long in hours. Okay, so I equals Q divided by T, but I want T, so T equals Q divided by I, 9,436 coulombs divided by 0.0750 coulombs per second. Remember, ampere, 1 ampere equals 1 coulomb per second. So coulombs divide out, but I want to get it from seconds to hours. So I'm going to multiply by 1 minute per 60 seconds. Seconds is gone, so I have to also multiply by 1 hour per 60 minutes. To get rid of minutes and leave it in hours, and so in terms of hours, 35.0 hours, 3 sig figs, and there you go. You'd have to, such a small current, you'd have to apply it for 35 hours to plate 10.55 grams of silver. So there you go. And that concludes this video.